This episode of Liquid Assets is sponsored by HASA, the leader in water treatment solutions. HASA delivers eco-friendly, reliable, and cost-effective water care and has been keeping communities safe, one drop at a time. They've been at it for more than 60 years, and you can learn more about HASA by visiting hasa.com. That's HASA, HASA.com.
Welcome to Liquid Assets. Liquid Assets is a podcast that focuses on the intersection of technology, management, and business, all as it looks at the world of water. Today we have an awesome guest for you. We have Alexis de Kerchove from Xylem.
Hi, my name is Alexis de Kerchove. I am Senior Director for Client Sustainability at Xylem, and I look forward to the conversation.
I want to jump right into the meat and potatoes, as we say in the US. And we were talking before I hit the record button about you saying that climate mitigation is not a burden. Can you explain what that means? How does that work within your context, within the context of Xylem? Let's just unpack that a little bit.
Climate mitigation until now is being explained as an additional task and obligations for a lot of organizations, especially in the water sectors, water utilities, which are already submerged with new regulations, new standards on treatment of complex pollutions, adapting on hydraulic capacity based on demographic growth. And at the end, when on top of that, utilities and the water sector needs to adapt and build resilience to climate change, we talk about reducing greenhouse gas emissions, it becomes slightly or quietly overwhelming. However, when you look at the core emission sources of greenhouse gas within water and wastewater management, many of them relates to inefficient use of assets or processes that ultimately the core business of those organizations, meaning trying to deliver efficient access to water and sanitation across the world. The first objectives that quite often we aim at supporting is improving the operations of those processes and assets in management and in operation, let's say. Energy use is critical to be optimized. And then second, biological treatments, meaning addressing activated sludge, which is a core sources of fugitive gas emissions, nitrous oxide and methane. Optimization of those processes can lead to tremendous opportunities in mitigating those emissions.
So you kind of mentioned a few things here that I want to jump into. The first at the top line, I loved your statement of water utilities' main goal is to efficiently deliver clean water. The problems right now with the way that the world is changing, the way that geographically there's more and more population in different cities and different areas. I mean, if you just think about the problem, you literally have to get water, you have to treat it, and then you have to transport it somewhere. And the two things that you mentioned was around energy and then biological treatment. Let's kind of zoom to the top really quick and look at these two problems that you mentioned. There is populations that are moving and that are changing in kind of rapid pace, and the climate is changing, right? Things are different in the way that you get water, the way that you treat water. If you look at the efficiency, as you mentioned, is there just anything from the kind of first two root causes of population changing and climate change in general that the water industry should look at? What do those problems actually unpack? What are we looking at when you see populations moving and climate change existing?
Okay, looking at the demographic first, there is a global increasing need in capacity into delivering water and sanitation services. That means, and the problem relies on the fact that especially in global north or in the Western world, we are relying on an existing infrastructure that is extremely old and usually limited in space because the urban environment is already quite well built and there's not that much room to add additional network or reservoir or infrastructure. The fact that the infrastructure is old, quite often 50, 60 years, it means that it needs to be repaired or replaced, and that the limitation in space makes it hard to build additional hydraulic volumes to treat and handle that water. That is one of the root cause of some of the problems in efficiencies. When we talk about climate, the main issue is that we have now unplanned activity, unforecastable future of events we talk about droughts, seasonal droughts. Now we can say that every single country in the world is living sometimes during the year droughts. The same for flooding, extreme weather events on the other side, so too much water. And the problem is how to handle this gap of scarcity of water or excess amount of water when you don't know when they're going to happen and where they're going to happen. So building that resilience in response to secure the quality of the service and the protections of the citizen in terms of health is critical. Those are two really massive priorities that we see as top of the list for the utilities, but which still can unpack a huge amount of potentials for reducing emissions of greenhouse gas if the solutions put in place are done in the right way. And quite often we rely on looking at solutions and technologies that have been used for decades because people like to feel confident about what they invest in, right? It's the nature of everyone here. Utilities, the same way, will look into, okay, how can I increase my hydraulic capacity by building a new plant or a new network or a bigger reservoir? The same for building resilience, or we need to build the same for resilience. We will need to desalinate because that's a technology that is being used everywhere. The same for flooding management, building new channels to accumulate that rainwater and stormwater that actually comes only, once a year. The key is to look into alternative solutions prior to the old solutions. The old solution is quite often based on new gray infrastructure. The new solutions that have been developing at a really high pace over the last 10 years are digital solutions or nature-based solutions. And you'll hear about them more and more coming up. I mean, we hear cases of in China or all around the world developing like sponge city, absorbing stormwater just by nature-based solutions. We hear a lot of solutions in the US or in Europe of digital machine learning solutions coming in place and taking advantage of existing hydraulic space in the network and optimizing it so that when a stormwater event comes, it can absorb the volume by first displacing existing water in the network to empty space, making more space available where there's actually a rainfall, so they can be absorbed under the ground in the network instead of flooding that area. So those new innovative solutions that are still trying to be fully adopted exist, but we need to accelerate this adoption to address the mitigation issue.
That's super interesting, actually. I want to explore a few of those digital technologies that you were mentioning. I love this dichotomy that you mentioned. It's come up a few times on the podcast of utilities will look at existing decades-old technology because it's safe. And the water industry is one that is a lifeline, right? I mean, there's no doubt that cities and areas, people cannot survive without water. And so safe distribution of it is obviously very important. But kind of from what you're talking about and what I love to explore on these episodes what are these new technologies? I love this sponge idea that you just mentioned of sponge cities. Like you just said, in the US and in Europe, we have machine learning, so we can kind of properly know where to divert the water. But if you were to maybe step back for a second and look at like 3 technologies that you want to explore, 2 technologies, whatever they are, can you kind of list those out, maybe dive into things for the audience of what is up and coming and what should utilities be looking at in terms of mitigation?
If we, as you said, step back and look at the core problem statement that we highlighted, your first question is, how is mitigation not a burden? Well, when we look at the operations of our water and sanitation services, the main emission sources of those operations comes from 2 origins. First, the use of fossil fuel energy, usually electricity, in the operation of the infrastructure. And then second, the emissions of fugitive gas, meaning nitrous oxide and methane, out of the biological treatments, activated sludge treatments. So let's have a deeper look into those 2 emission sources or origins. Energy. We know that globally, there is a shortage on renewable energy sources. There is only about 20% globally available energy sources for the global consumption. So that means that not everybody will have access to it. So that means that the first thing to do is intend to reduce the consumptions of energy during operations, gain energy efficiencies. Mechanical and electrical solutions have their own limitations. You will always take energy to move water from one place to the other and to treat it. However, the process at which it's being done can be optimized quite heavily. And that is by making sure that you have the right information at the right time to take the right decision. And that relies on data. The data is collected by sensors. The data is being collected into a data lake that enables us to organize that information and then analyze it to make the proper information for decision making. The human brain is the way it is. We have families, we have personal lives, we have our own limitations that does not enable us to have constant overlook of a process and decision making. So now with machine learning tools and more reliable on-site sensors, there is a huge opportunity to accelerate the accumulations of data, the right amount of data, meaning quality data. You cannot, what comes in defines what comes out. So it's clear that it's important to have the right quality data. And then the processing of that data to generate the information needed for taking decisions. Technologies today, especially in wastewater management and water management, relies on pumping the water and treating the water. Pumping the water, solutions now exist to improve the way a pump operates and adjust its operations based on the demand and the amount of water to be moved around. You might think, oh, why pump are so important? Well, pump usually can vary in between 7 to 50 or even 70 or more kilowatts. The small pumps, the problem that they have is that an utility will have thousands of them. That means that for someone to operate and make sure that each of them is at the right status, meaning operates efficiently at its duty point, is extremely difficult. So asset management becomes truly a pain point there, because if you don't do it properly, you will use your service car and travel hundreds of miles left and right just to check if the asset is properly operating, which is, of course, a waste in manpower, but a huge source of emission source of gas from fossil fuel use. Asset management can be done. Operation of those assets through intelligence of integrated functionalities within the pump that detects its environment, operates self-clean, adjusts its speeds based on demand is critical. So their digital information is providing a huge improvement in the efficiency of the asset itself, but also sends back information home to say, I have a problem. I need to be prioritized to be maintained or replaced or you name it. So that's at the edge level, meaning in situ in the environment. Now, once you collect that information and have a holistic perspective of your infrastructure at the network level, then you can start taking much bigger decisions in terms of like what needs to be replaced, how or where should my water go in order to prevent a flooding, as we said, and associate that data with external information that enables you to forecast. And the concept of forecasting now is extremely valuable for the utilities, because just a 6-hour forecast on a flooding enables you to adjust your network to prevent a localized flooding of a school, of a hospital, of a residential area, which otherwise would have been dramatic for the local residents. And that the digital solutions enables to do that forecasting forward. When we go on the process gas emission on the activated sludge, the other category, utilities and in a very normal way, for the last 100 years, we rely on the treatment of our human wastewater, based on biological activity to remove nitrogen and phosphorus. That means that nitrogen and phosphorus are removed with bacteria that are breathing and accumulating those nutrients and eventually breathing it out into different forms, either nitrogen itself, or nitrous oxides if the system is not efficient enough. Biological treatments requires a huge amount of energy because those bugs need to breathe, so you need to aerate the water. And then second, if it's not done properly, they will breathe, but with a high amount of nitrous oxide in the emissions, so which makes it not very efficient. So conceptually, you remove the nitrogen from the water to prevent a discharge in a open water or reservoir you're trying to protect on the biodiversity of ecosystems, but with the side effect of releasing a huge amount of nitrogen under the form of nitrous oxide in the atmosphere, which equally impact our environment. So at the end, using biological treatments for the last 100 years has been one of the key reasons why we're sitting where we are today with the climate crisis. There are lots of different ways to address this. First is optimizing this existing process, intending to understand with, again, machine learning and sensing, where are the key or main sources of emissions, because you have several basins, several treatment plants. The key is to detect the one that is the most ineffective or inefficient, and then also collect that information with true measurements. It is important to understand where are the sources and how much they are emitting so far. And then that information, that data, can feed and build boundaries into a machine learning system that enables them to forecast how much am I supposed to aerate, so that with the residence times in the basin and so on, I can meet my quality standards of discharge on the water side, but also mitigate emissions by optimizing the way my bugs are breathing. Are they breathing the right amount of oxygen at this time, and then, emitting just nitrogen and not nitrous oxide? So that's critical. And so now machine learning for mitigation is the key step forward, reducing emissions of process gas.
And do we, from a technological standpoint, do we already have sensors out there that are able to feed back this information, or is it something that we still need to develop? Is it just more of an execution problem?
It's very much an execution problem. There are sensors available, and also growing amount of models that relies on less sensing but more modeling. Both are there and under development. That means that it's moving extremely fast. The sensing on the measurements of nitrous oxide and other gases in the liquid phase exist and has been used already for decades. The sensing of gas emitted in the gas phase, so after the stripping of that gas through aerations and emitted in gas form, is also quite available. Nothing is ever perfect. It requires maintenance. It needs to be handled. But that's the same for everything else. And it's part of the daily routine that we do on maintaining a business in operations, right? You have sensing and you have the regular maintenance. But the technology is there to provide the right amount of data for optimization.
Really interesting. I want to kind of just re-summarize this back to you also for the audience. It seems like there's kind of, going back to the root causes, we have two major problems, right? There's this existing infrastructure issue, cities having pipelines that we built 70, 80, 100 years ago that we're relying on, with additional population that is moving into these cities. And the second problem are these black swan events, right? You have flooding on one side, and then you end up having drought on the other side, and you're this pendulum is moving from one side to the other. In looking at our existing infrastructure, I love the way that you say that we can take what we currently have and just make it more efficient, right? If you have an engine and you can have it not run at 100 miles an hour, but 200 miles an hour, and you can go a longer distance, you can take your existing infrastructure and basically just make it more efficient. When we look at the holistic network level of sensors and the pump issues, one of the questions that actually came up was how much of a win really is this? Like, if I look at the Pareto, the 80-20, are we solving the bulk of the problems by solving this pump issue, or is there just a bunch of small changes that kind of then cascade into a much larger aggregate? Like, how much of this pump issue actually is the problem? What's the percentage, if you know?
When we look at the wastewater management of an utility, so each utility will target two big segments: the drinking water distribution and then the wastewater management. If we only look at wastewater management, the emission sources from that activity is distributed among the energy use and the process gas emission mainly. And you can think that electricity use can go from 30 to 50% of the emissions, and the process gas from 50 to 60%. So process gas is usually slightly more important. Now, digital solution on existing infrastructure to reduce energy use can lead to cutting down those energy use already by 50%. Safely. We can mention that by making sure that assets operate at the right duty points, that they're being maintained at the right time with spare parts, with replacement when needed, and that create a huge impact on how a network is being operated. And the same on the treatment side. Cutting down energy use by operating better the blowers and aerations of the existing treatments can be cutting down a huge amount of energy. One part that is really troublesome in the wastewater network is how those pumps get clogged with everything we dumped in the bathroom. Towels, teddy bears, you name it. It goes into the drains and clogs those assets. Now, building an asset that has intelligence to self-clean itself, meaning shifting the directions of the propeller in the other way so that it can expose the debris and then restart in the right way and push the water again in a very effective way is critical. And that the solutions that currently Xylem provides in that sense, and we see growing in the market, is it cuts down the clogging events by 99%. Every single time you get it right. And that's a tremendous progress in how assets can be operated more efficiently without requiring unplanned service events, meaning having a call out to the operator saying, come now, because otherwise I'll have a flood of sewage water in the local pumping station.
Makes complete sense. If we move to incentives now, we were talking about this earlier before we hit record as well. When you look at like regulation, the corporations and private entities contributing here, where does I don't want to use this word burden, but where does the responsibility fall in making these changes that we're seeing?
There is not a straightforward answer to that, and the incentives for everyone might be varying quite a bit. The utility generally are driven by regulations. You need to meet standards, and they're very complex and constantly changing. And to the defense of utility is really hard, and to their credits, it's really hard to meet all those standards at once with the amount of funds available to support it. Let's not forget that usually the money available for water services comes from the tariffs on the water or taxes, and that is being regulated as well. So you don't have an unlimited amount of money to pour into your infrastructure. So regulations is the main driver. In Europe, we see a lot of shifts and a change in the regulations regarding wastewater management, the same on drinking water, the same on pollution. That Europe is on a trajectory to be net zero emissions by 2050 with the Green Deal put in place. In the US, we see a different approach, which is by driving more subsidized money towards environmental protection, which is a different tool that accelerates also a transition and transformation. So you have those two big drivers. We see more and more volunteering approach, meaning that the utility wants to be outperforming versus others. So they're setting up new industrial standards because they understand that on their own that environmental protection is their duty, and then making sure that they mitigate their emissions is a priority for them. And the third driver that I consider quite important is the one coming from a push from the private sector, meaning all the big industries that are providing and supplying equipment and infrastructure to the utilities are themselves being driven to go to net zero because they're shareholders and the investors pushing for that. The only way for private sector to meet their targets is by making sure that their value chain, meaning their suppliers and customers, are onboarded on the same journey, meaning committing into it and progressing towards those goals. And so the private sectors is investing in their value chain to incentivize and to help and partner and co-develop towards solutions that will help them meeting also net zero targets. And I think that's it's a one of the beautiful way of the way carbon accounting is being designed is that to get to net zero for an organization, there needs to make sure that the value chain, upstream and downstream, are also onboarded on the same journey. And so the private sector intends to drive utilities and others to go on that journey as well.
And when we talk about this journey, I want to get into a little bit of the tactical nature of it, right? Is there a template of data that I know that I can say, hey, my journey is in decreasing these types of greenhouse gas emissions. I'm going to work on efficiencies. I'm making sure my 1,000 pumps in my utility network are 20% more efficient than they were yesterday. Is there a template or a guidebook that is, journey A, journey B, journey C, let me take 20% of this and 10% of that, that's our new packet now? How do we speak the same language is my question.
I would start by saying that the greenhouse gas protocol has set up a way to account for carbon that is quite clear, and anyone starting on this journey needs to start setting up a baseline. Where am I sitting today? So addressing a basic accountability of carbon across their organizations and value chain is important. And we define, according to the protocol, you define that as scope 1 and 2 for your operational emission, and scope 3 for your value chain emissions, meaning suppliers and customers. Now, where we're facing challenges and a few bumps on the road on this journey is that, the world is big and everybody has great ambitions to move forward, but we are not always aligned in how to adapt the protocol to our sector, winning the water utility sectors. And we see across the globe lots of initiatives of adapting the protocol to utilities with the rights, with calculations and methods that diverge region by regions and requires standardizations. The same on the type of information required to suppliers like Xylem and others. And so that creates, let's say, some complexity and double efforts in providing the information. Giving an example, the UK has been onboarded on this net zero journey for water utilities for the last 10 years. The regulator, Ofwat, is challenging the utilities to be net zero by 2030, maybe with additional time dedicated for the scope 3 management. But in general, the regulator provided an accounting book that enables the utility to set up their baselines and make progress towards it. Now, what we're realizing is that that workbook has divergence and methods of calculations that needs to be aligned, especially if we want to support other countries to do the same thing. And we need to make sure that we understand which guidelines we provide to utilities for addressing their accountabilities on carbon and progressing that way. When it comes to Xylem and when it comes to accounting carbon from the suppliers and embedded carbon in infrastructure, it is important to gain accuracy in the accounting. Right now, I advise usually our customers to directly reach out to Xylem to make sure that they get the most accurate emission factors intensity that correlates to our business into our product so that they can accurately account it based on the activity that they generate with us. And that's the most straightforward way to do it instead of taking a sectorial emission intensity that will generate a lot of error in the accounting.
Makes sense. And one of the questions that's actually coming up right now is, I remember in a few interviews, people were like, there is a supply issue of folks in the water industry, right? There's this, I think they call it in the US, the silver tsunami or something. There's a bunch of older folks that are basically leaving the industry. If you think about just a supply of the workforce issue, utilities not only having to manage their quote unquote day-to-day job, but also take on responsibility of doing these sort of accounting measurements, even coming up with the baseline. There seems to obviously be a little bit of a setup here. What would you kind of advocate being the best way for a utility that's already understaffed to get this? Because it seems like it's it's almost a non-negotiable, right? You kind of have to do it because we have to be efficient. We have to lower greenhouse gas emissions. What's your suggestion there?
It's a good question, and I'm not sure that the answer is going to be that easy because of because low capacity and people being stretched in all directions in the utility, and it's quite often the base in others and in other sectors. The one positive side that I see into this aspect is that addressing sustainable topics and environmental protection and now climate crisis are becoming skills that are extremely attractive for youth. And you see growing amount of resources and experts in that field because it is a topic that is extremely attractive from the younger populations. And so the same with IT or AI, we see availabilities of extremely well talented and expert people that are eager to learn more about it. And if you don't have capacity to recruit a new person, quite often within an organization, there are existing talents who are more than willing to jump on board of the quest and learn about it and address it, sometimes with extra time. But the fact that everybody's impacted by the climate crisis makes it a personal problem. And I believe that that can help on the resource issue as well.
That actually is a perfect segue into your background. I know you transitioned from chemical engineering and academia into working at Xylem. Can you just kind of, for the audience, maybe talk about your journey there and what got you to kind of make that jump? I know there's a lot of folks that listen to the podcast that are thinking about a career in water, or maybe are just interested in it. What's your story there?
It's a long journey because I never left the water sector. I started through doing my majors in chemical engineering and biology, and my dream was to do biology, but I had a great personal advisor named my dad who told me, it's great to do biology, but what about degree in engineering? And I was like, great, that sounds cool too. So instead of picking one or the other, I did both, which opened actually quite a few more doors, to be frank with it. The first one was to be able to do a master thesis in deep sea organisms on my major, on my biology side. And that really opened up a lot of views of how the world needed protection. And then when it comes to chemical engineering, I've been able to address this with great advisors on my PhD, who basically made me understand that water treatment is a fantastic world to innovate. And I did my PhD at Yale with Menachem Elimelech, who is one of the leading entity on membrane and water management. And I really recognize that the talent that he had to listen and engage with the young talents and promote them forward. Now, coming out with a PhD in this world, it's not always easy. And I had also an interest in traveling back to Europe. So the corporate world or the private sector world was an entry door that was quite interesting for me. And so I started there with process engineering in a company called Suez, which is leading on operation there. And then after a few years, jumping into Xylem's in the same type of role, process engineering. And I have to admit that starting with this process management is fantastic. For me, it was meeting my need of being hands-on and understanding so much about technology and what's possible with water, and developing the ground base of like, okay, what are the real challenges that we're facing today between pollutions, capacity needs, skill missing, and so on. And then finally, being at Xylem, the largest global company on solutions and technologies that on the water sector, is a fantastic playground for any development and career boost because everything is possible. Over 12 years at Xylem, I had 4 fantastic roles, transversal, growing up in all direction, and I think that it only makes you passionate grow when you get to move around like that and keep learning and challenging yourself.
When you studied the deep sea organisms, what you had mentioned, it kind of really opened your eyes to the importance of water and kind of the world in general and the deep sea organisms. What did you learn? What were those findings?
First of all, I was checking a box on one of my dreams, and I had, again, a grade master thesis advisor who enabled me to go by myself to Southampton in the UK, board a research ship outside of offshore of Ireland, on top of one of the nicest abyssal foss in the Atlantic. And they're sitting on a boat for 6 weeks with no sight of land at any time is something that is unique for a human being, I think. No, not that many people get to experience that. The shipping industry does, and researchers do as well. Their facing storms is very impressive, and that woke me up, literally. And then also waking up every morning at 3 in the morning to actually collect fishes from a deep sea collections for research purposes makes you understand that we have a wealth of ecosystems and life that is untapped, but that we need to protect, like our own life, if we want to subsist here. And I'm one of those people that is more of a dreamer side. You have those that are very pragmatic and always like having to touch the ground. I'm more of a dreamer side that makes me move forward. Being there on that boat in those conditions just kept me driving. Anytime that today we're facing challenges, it reminds me of what we could face there and what we're working for, and it helps.
Alexi, I ask everybody this question before we close out the episode, and it's: do you have a book, a TV show, or a movie that has had a profound impact or changed your view of the world?
I have one movie that has always been dear to me. It's The Big Blue. It's the story of it's a French movie. The title in French is The Grand Bleu. The story of a free diver going in the abyssal depth without how do you say, in apnea, let's say. The charismatic person is really powerful. And the finding boundaries between nature and society is extremely challenging for that person in the movie, and it's breathtaking, I think.
Awesome. We'll definitely put that on your show notes, The Big Blue. Alexi, thank you so much for joining us today.
Pleasure. Thank you very much for having me here.
And for all of those of you out there, you can listen to Liquid Assets wherever you get your podcasts, be that on YouTube, Spotify, or Apple Podcasts. Go to liquidassets.cc and drop your email to subscribe to our next episode. Thank you all for listening.